Hi, and welcome to the last video in See the Light, Easy Wins to Improve Your Asset Framework Experience. Congratulations on completing the lab. You have gone through a fair amount of material, and the point of this video is just to sort of wrap up the class. We'll go through a breakdown of the issues you found, the workarounds and best practices that were applied, and then we'll point you in the direction of a few resources that you can hopefully look at to further your learning. Now, when we started off the class, we were exposed to a couple of issues in PyVision, and these were discovered to be the result of not applying best practices in the asset framework. The engineer pointed out 6 issues, and going through them, the first one was that the asset FFS05 was not available in the drop-down list when you wanted to switch between different assets. When doing our research, we found that FFS05 wasn't using a AF element template. So what we did is we went ahead, assigned the template to the asset, and once we'd done this, the asset became visible in PyVision. Now the best practice here is to always use AF templates. Not only does this make PyVision displays reusable, but it also makes it much easier to access information from your Pi system through any of our client tools. The second issue we faced was that the trends and statistics for FFS units 3, 4, and 6 were identical. Now these assets had an additional attribute called sugar grain size. This was configured using the allow extensions option. Now allow extensions allows you to copy and paste and add extra attributes to an asset even though it's based on a template, and this is where that problem arose. By using copy and paste, all 3 of those assets were referencing the same Pi tag. What we did is we used a derived template for these units that just had the sugar grain size attribute, and that fixed the issue. Now our best practice here is that derived templates, sometimes in conjunction with the excluded attribute property, is the way to ensure consistency in your asset framework experience, especially when you're dealing with assets that may not fit the mold identically. Issue 3 was that the sealer temperature was showing values well outside the range. We were getting values between 40 and 60, and the expected range was supposed to be between 70 and 270. Now, when we did our research, we found out that the devices were purchased in Europe and were calibrated to record temperature in Celsius. However, the default temperature in Asset Framework was Fahrenheit. So what we did is we set the source unit of measure on the sealer temperature attribute to be Celsius. That way, Asset Framework knew that it had to convert between Celsius and Fahrenheit. Now, the best practice here is that AF can automatically handle units of measure conversions for you. However, in order to make good use of this feature, you need to specify your units at all points so you don't get trapped by using the default, which in our case was wrong. Issue number 4 was that the attribute last service date slowed down the loading of PyVision. Initially, it took a long time to add to the display, and if you did the lab over multiple days, you would have seen that whenever you loaded up the display, it took a long time to populate data. This was extremely evident in Pi System Explorer, where it often took a long time to retrieve the data reference values. Now, doing our research exposed that there was an externally linked AF table, and it had a huge amount of rows. 300,000 rows is unrealistic for a system this small, but on some sites we do see people bringing in tables of that size. So what we did is we parameterized that query, and this greatly accelerates the data retrieval time because you're not returning the entire table, you're only returning the values that are pertinent to you. So our best practice here is that parameterized queries are your friends when you're retrieving data from exceptionally large tables. The 5th issue we ran into was that FFS04 had no data for the nominal max throughput attribute, and it was the only asset that had this problem. So our solution when we went and had a look at it was that the nominal max throughput was relying on the model attribute to use as an input for a table lookup, and the model attribute was set using a static or none data reference. What this meant is that it allowed someone to type in MF Techno with a typo, so they'd added an H when none was needed, and because it was misspelt, it couldn't resolve against the table. In order to fix this and remove the possibility for human error, we used an enumeration set that provided a drop-down list of the potential models. And our best practice here is that enumeration sets help avoid typos and ensure consistent nomenclature throughout the entire database. Then our sixth issue was that the engineer saw the word faulty and jumped on it, so the title of the display wasn't updating. The solution here, instead of using a static text box to title your PowerVision display, is to use a set of attributes which are built using the string builder. Now, best practice is that the string builder data reference, along with substitution parameters, can be a very powerful tool for handling string values and also creating dynamic pointers. In our case, that was the title for the PowerVision display. Once we'd fixed all the issues that the engineer found by applying best practices, we moved across to asset analytics, and we just had a look at a couple of the best practices you can employ there. Now, the first one we looked at was the usefulness of expression variables. In our sandbox environment, we were using the tag average expression, and we were calling it 6 times. What that meant is that we were doing 6 independent calls for data to the data archive, which was greatly slowing down our calculation time for the analysis. So what we'd in the production environment, we'd set up a variable to run that tag average value, and then we reuse the variable in multiple steps. So by splitting up your calculation into multiple variables, not only is it easier to read, easier to troubleshoot, it can also improve the performance by reducing the number of calls for data to the data archive. The second issue we had a look at was the importance of analysis scheduling. Now, this often relies on just a lot of common sense. If you are only going to be looking at a report once a week, there's probably not a need to run that calculation every minute. If it's a summary calculation, you could maybe run it once a day at midnight when the load on the system is low. You can also have a look at periodic event-triggered scheduling for your analyses. And that's fantastic when you need to trigger based on a specific value updating. So scheduling your analysis, the standard 1 minute or 5-second trigger is often not the best decision to go with. The third one we had a look at in the videos was the advantage of roll-up calculations versus formulae. Now, the formula data reference is very easy to configure. It doesn't require storage of pi tags, but it is a quote-unquote dumb calculation. It's not able to handle with it's not able to deal with increases or decreases in the number of dependent calculations. So the roll-up analysis is exceptionally useful when you're doing statistics for a section of your plant, whether that's minimum, maximum. Maybe you want to find out how much power a specific area of your plant is doing. If every device in that plant has a power input or a current draw variable, you could do a roll-up to calculate total kilowatt hours for this section of the plant every day. That was the last of the videos we went through. Then there was some reading for you to go through, and in the analysis section, we spoke about the choice between consolidating or splitting up expressions into multiple different analyses. And this often depends on calculation dependency. Do they need to follow a similar schedule, or what's going to make your life easier managing the calculations in future? And then we had a look at analysis in a warning or error state, why you should disable those. Basically, every 15 minutes, if there are analyses in error, the analysis service will try and start them up. That puts load on the system. So if you can disable analyses in warning or error state, you'll reduce the background load on your analysis engine. Now, a couple of extra resources that we will recommend. The first two being learning.osisoft.com and pisquare.osisoft.com. Learning.osisoft.com is the OSIsoft public learning page, where you can go ahead and find all of our online courses, classroom courses, and it's a fantastic place for you to go and expand your knowledge. PySquare is a slightly different website. This is our user forum, where not only do you have people from OSIsoft contributing, but it's our customer community contributing as well. So if you want to look at cool uses and things you can do with the Pi system, or the solution to a particularly tricky problem that you don't think warrants a tech support case, pisquare.osisoft.com is the place to go. It's also where you'll find our asset-based analytics kits, example kits, and they're a great place to jump off. So you want to look at condition-based maintenance for your pump house, head over to pisquare.com. You can download the CBM asset-based example kit, and that gives you a rough idea of how to go about that. The next two are courses. If you want a ground-up perspective of asset framework, building Pi system assets and analytics with AF is a great course to do. This is an in-person course. You can either have a OSIsoft engineer come to your site, or you could come to one of our public training centers. And this goes through the use of asset framework from I've never seen the application before, all the way through to being able to use event frames and notifications and doing your analyses. We do an OEE calculation. By the end of that, you have the grounding to go ahead and build out your asset framework. Now, if you've used the material in this class and you're wanting to know a little bit more about how asset analytics works, how to improve your performance, there is a fantastic online course called Optimizing Asset Analytics for Better Performance. I would definitely recommend that you go and have a look at that. Thank you very much for attending the course. I hope you managed to get something useful out of it, and have a great day. Bye for now.